Good evening, everyone. Am I audible? Am I audible? Am I audible to you? Good evening. Okay, good evening. I'm hoping that I'm audible to you. And welcome to today's YouTube live session, Unacademy's YouTube live session. We are going to continue on alcohols, phenols, and ethers. My name is Rashmi MR, and I welcome you to this live session. We will be continuing today preparations of alcohols using carbonyl compounds. Okay, good evening, Alvisha. Good evening. Avril, good evening. Good evening. Okay, yes. Before we start, let me tell you about how to subscribe or why to subscribe for Unacademy Plus classes. Students, if you want to have a comprehensive batch, that is physics, chemistry, mathematics, biology, or physics, chemistry, biology. If you want to have a comprehensive batch, you can subscribe to Unacademy Plus classes, where you get a comprehensive live batch with complete syllabus preparations. Okay, within months, complete syllabus preparations will be there. So you will get premium content in affordable price. I'll come back to the price in a bit. Okay, let me tell you what are the highlights of this batch. One is well-structured live courses, dedicated live doubt clearing sessions, quizzes, test series, daily practice problems, full which will all help you in self-analysis. How much of the topic you have understood, you can analyze yourself, and you find that you need to learn particular chapter or a particular topic again. Okay, need to learn about it again because of your single subscription. How long as you have a subscription, you have unlimited access to Unacademy library. Okay, recorded library or other classes which teachers are same topic is taken by some other teachers. You can go attend, learn, so that you can have an all-round development, the complete syllabus preparation. Students, you can subscribe it for 12 months, 6 months, or even 1 month, and you have to pay for 12 months 12,375 rupees, or 6 months 10,125 rupees. In fact, you need not even pay this much if you use my referral code Rashmi 2020, because you will get 10% discount. Use my code Rashmi 2020, so you will get discount. Students, not only you, your neighbors or your relations, your friends who are in PUC, first or second PUC, let them also know, so they also will get benefit. So use my referral code Rashmi 2020, get the full extent of the benefit. Okay, yes. Good evening, Ananya. Good evening, Alina. Good evening, Nikita. Good evening. Good evening, guys. Okay, as I was telling you, we will continue preparations of alcohols. We had learned preparations of alcohol using alkene. You remember, we have learned a mechanism also. So today we are continuing preparation of alcohols from carbonyl compounds. What are carbonyl compounds? C double bond O. So this is general representation of carbonyl group. See, this is carbonyl group. So these two groups, what are these two groups? Decides what kind of a compound you get. If both are R group, okay, both are R group. Carbon has 4 valency. Okay, here 2 valence with oxygen, and third valence is R group, fourth valence is R group. What is R group? Alkyl group, like CH3, C2H5, and all these groups. Okay, alkyl group. Then you have ketone. Can you have ketone? RC double bond O R. That is general formula for ketone. Or if you have double bond O, one group is R, other group is H if you have. So you have RCHO, that is aldehyde. Aldehyde. Okay. Or if you have C double bond O, okay, R OH like this, that is RCOOH, carboxylic acid. Okay, or if you are OR, then you have ester like this, OR, ester. Or if you have no RCOCl, here Cl you have, that is RCOCl, you have acid chloride, and so on and so forth. So every one of these compounds, carbonyl group will be there, CO double bond O group will be there. That's called as carbonyl group. So today we are going to learn using carbonyl groups like aldehydes, ketones, carboxylic acid, and ester. So first let's talk about aldehydes and ketones. If you are using aldehyde, That means if you have H and R like this aldehyde, you will get the primary alcohol. CHO is converted into CH2OH. That is R C double bond OH. Okay, here bond breaks, H2 here, H2 here you add. So you get RCH2. Okay, of course the O is there. RCH2OH. RCH2OH. You are adding hydrogen, you are carrying out hydrogenation in the presence of a catalyst. So it's called as catalytic hydrogenation. Catalytic hydrogenation. Catalytic hydrogenation. So catalytic hydrogenation or reduction. Now reduction can be carried out by by catalytic hydrogenation using platinum, palladium or nickel. Okay, that is one way of carrying out reducing agents. Or you can also use the sodium in ethanol, C2H5OH, or you can use reducing agents like strong reducing agents like lithium aluminium hydride or sodium borohydride. All this can be used as a reducing agent to convert carbonyl compounds to alcohols. And if you use aldehyde, you get primary alcohol. See, for example, ethanol. This is ethanol. 2 carbon, is it not? 1, 2. So 2 carbon means ether between carbon single bond. See, if you see like this, CH3, C double bond O, H. Between carbon single bond. Correct? Carbon single bond is Al. Remove E from ethane, write Al. That is for aldehyde. Carry out catalytic hydrogenation. CHO is converted into CH2OH. You will get primary alcohol. So use ethanol, you get ethanol. E is replaced by OL. If it is ketone, RCOR, CO is converted into CHOH. So across carbon double bond, it becomes O minus. That also will get H. Carbon also will get H. See like this. RC double bond OR becomes RCO minus. Okay, R. So across this, you get H. So RCHOH like this. RCHOH. Across the carbon double bond, HH you are adding. Only one molecule hydrogen you are adding. So RCHOH you get. That is secondary alcohol. You get secondary alcohol. So aldehyde primary alcohol. Okay, aldehyde primary alcohol. So if you want an example, CH3, C double bond O, CH3. Altogether how many carbon atoms? 1, 2, 3 carbon atoms. So propane. Okay, instead of E you write ONE, propanol. Okay, ketone ONE you write propanol. That is acetone. This is nothing but acetone. Acetone is also accepted. Acetone. You carry out hydrogenation using lithium aluminium hydride or sodium borohydride. Here sodium borohydride is written. Okay, or like this. Any one of the reducing agent you can use. What do you get? CH3, CHOH, CH3. So aldehyde group. CO it becomes a CHOH. Okay, so 1, 2, 3. So 3 carbon atoms. So propane 2. Second carbon has a OL. Propanol. Propane 2 all or 2 propanol. 2 propanol is the compound. So propanone becomes a propanol. 2 propanol because second carbon atom is the functional group carbon atom. So that carbon atom becomes a CHOH. Okay. You get secondary alcohol. So you take aldehyde, you get primary alcohol. You take ketone, you get secondary alcohol. What about carboxylic acid? See, carboxylic acid is not as easy as your aldehyde or ketone. Even esters can be actually reduced easily. Carboxylic acid requires a strong reducing agent like lithium aluminium hydride followed by hydrolysis. Then COOH, carboxylic acid, COOH is reduced to CH2OH. That is primary alcohol. You get primary alcohol. So carboxylic acid also converted into primary alcohol. That is COOH is reduced to CH2OH only in the presence of a strong reducing agent like lithium aluminium hydride followed by hydrolysis. Okay, so carboxylic acid. Ester undergo easily actually. Okay, it can be easily reduced. Even see catalytic hydrogenation. Using catalytic hydrogenation, you can convert ester to alcohol, primary alcohol. See CH2OH. So RCOO, okay, breaks here. RCH2OH. This becomes RC double bond OO R dash. Is it not? See the bond breaks here. R dash OH you get one alcohol, and RCOO becomes RCH2OH, primary alcohol. Now to give an example, how do you get ester? Carboxylic acid when reacts with alcohol, you get ester. in the presence of sulfuric acid as a catalyst. You have to add few drops of sulfuric acid as a catalyst. If you're carrying out, let's say, in a test tube, if you're carrying out reaction, okay, you take carboxylic acid, you take alcohol, and you add few drops of acid, sulfuric acid as a catalyst. So, and you heat. So, alcohol and carboxylic acid reacts to give ester. Okay, whichever alcohol you've taken, that alcohol you get back here. Okay, and the carboxylic acid part is what converted into primary alcohol. So carboxylic acid part of ester is converted into primary alcohol. I hope you understand. So ester is easily reduced to primary alcohol even by catalytic hydrogenation. In fact, carboxylic acid requires the stronger reducing agent like lithium aluminum hydride. Okay, so bottom line is this: if you have aldehyde, if you have carboxylic acid, if you have ester, okay, you get primary alcohol. If it is ketone, you get secondary alcohol. So using carbonyl compound, either you can primary or secondary alcohol can be prepared. Now, example for ester. Okay, example I have taken CH3COOC2H5 ethyl ethanoate. This is ethyl ethanoate. Ethyl ethanoate. Okay, catalytic hydrogenation. So alcoholic part is CH3COOH group. This becomes CH3CH2OH. See, COOH becomes a CH2OH. This part C2H5 from the alcohol, that alcohol you get back. See, ethanol you get back. So you have, of course, one the same, but see, if by chance, if this is different R groups, if it is different, then it will be getting different primary alcohols. This is one and the same, okay, but just to show that a carboxylic part is actually converted into primary alcohol. If it is different alcohols you will be getting. If this was CH3, okay, CH3, then you get CH3OH, you get like that. I hope you understood. Okay, any doubt, students? Any doubt? Did you understand from carbonyl compounds? Do you have any doubt? Do you have any doubt? Did you understand from carbonyl compounds preparation? Okay, shall we go to the next preparation? That is from Grignard reagent. This is important preparation using Grignard reagent. Now, what is Grignard reagent? RMgX. This is Grignard reagent. Alkyl magnesium halide. Alkyl magnesium halide is Grignard reagent. Magnesium is bound to by covalent bond to an organic group, alkyl group. Okay, alkyl or aryl, can be alkyl or aryl group, R or Ar. Okay, and to halogen. The bond between carbon and magnesium is a covalent in nature. Bond between magnesium and halogen is ionic in nature. So this is ionic bond. Here you have covalent bond. Covalent bond. And Mg is an electropositive metal. It's an electropositive metal. Okay, so let's analyze the bond between RMg. Okay, this bond, okay, is a covalent, and carbon is bonded to magnesium, which is an electropositive metal. As a result, when this bond breaks, okay, heterolytic cleavage takes place. R you get minus, Mg becomes a plus because electropositive, it loses electrons. So you get carbanion. Okay, carbon carrying negative charge. You get carbanion is a predominantly obtained from Grignard reagent. So when Grignard reagent breaks up, you will get carbanion and Mg plus and X minus like this. Okay, two fragments. Magnesium carry plus charge, R will carry, the alkyl group carry minus charge. So you get carbanion. I hope you understood this. So this is how Grignard reagent, because the bond between R and Mg is highly polar bond. Highly polar. Carbon being more electron negative will pull the bond towards itself. So it is slightly negatively charged. So when this bond breaks, heterolytic cleavage, you get R minus carbanion. And Grignard reagent is reacting with carbonyl compounds. Okay, carbonyl compounds. Grignard reagent with carbonyl compound. What kind of a carbonyl compound? We are going to talk about aldehyde and the ketone. That's all. Aldehyde and ketone. Here, when Grignard reagent react with carbonyl compound, the carbonyl compound is the aldehyde or ketone. Okay, let's talk about aldehyde. The first aldehyde, HCHO. Okay, that means carbonyl compound. Okay, both are H. That is a methanol, formaldehyde. Okay, what happens? Okay, before I come to this, what is the general reaction? Let me tell you. Here, basically, addition reaction takes place. Carbonyl compound and Grignard reagent are added. How do you add? See, in carbonyl compound, the carbon-oxygen bond is polar because oxygen is more electronegative than carbon. So the pi electron cloud is pulled by oxygen. So oxygen becomes negatively charged, carbon becomes positively charged. So in Grignard reagent, you have carbanion. So the carbanion will attack the positive carbon. Because O is minus, Mg plus will be attracted to oxygen. So you get an adduct. Adduct is addition product. Addition product. You get an addition product. So just adding. How are you adding? You're breaking Grignard reagent into carbanion and a positive fragment of magnesium. Okay. So carbanion is attracted to the positive carbon. So carbon-carbon bond is formed. O minus will take up MgX like this. Addition product is formed. Which on hydrolysis, acid hydrolysis. Which on acid hydrolysis. Okay. What will happen? This O minus MgX. O minus will take up H plus from acid becomes OH. You get alcohol. Alcohol. MgOH. MgX will take up OH from water, OH minus. So you get basic magnesium halide. This is called as basic magnesium halide. So MgOHX is the common byproduct. So you get alcohol and basic magnesium halide. Now what kind of a alcohol depends upon what are these groups in the carbonyl group. See, what are these groups? What are these groups? If both are H like this, see, both are H. H, C, double bond O, H, that is an aldehyde. This is the first member of homologous series of aldehyde. That is formaldehyde. Formaldehyde or methanol, IUPAC's name. Methanol. Methane, M-E-T-H-A, E remove, write A-L, methanol. Okay, both are H. You're adding Grignard reagent to it. So you're adding R, MgX. You get an addition product. See, C, O minus will take up MgX. Okay, it already has a 2H. The R group from Grignard reagent will attack the carbon. So this is your addition product. Which on hydrolysis, acid hydrolysis. Okay, you can write acid hydrolysis. See, RCH2 is there. I will write is that RCH2. See, this carbon has 2 hydrogen, is it not? RCH2 OH plus MgOHX. And what is this compound CH2OH? Primary alcohol. So if you take methanol, you get primary alcohol. Did you understand this? If you take methanol, you get primary alcohol. Now what if you take ethanol, CH3OH, second aldehyde. Now CH3OH, CH3, okay, C double bond O, H you are taking. Let's take now CH3 MgBr. This is Grignard reagent. Methyl magnesium bromide, Grignard reagent. Again, it is this breakup as minus and plus. Carbon will pull the electron towards itself. So you will get addition product. The carbon already has a CH3 and it has a CH, is it not? So I will write CH3CH. This carbon will get the CH3 of Grignard reagent. So CH3 of Grignard reagent I will write here. And O minus will take up MgBr. Okay, you get addition product. Which on hydrolysis? What do you get? CH3, CH, CH3, O minus becomes OH plus MgOH, Br. And what is this compound CHOH? Secondary alcohol. Secondary alcohol. So you have to remember this here. If you take first aldehyde, that is HCHO, you will get the primary alcohol. Any other aldehyde of homologous series, it could be methanol, it can be ethanol, propanol, butanol, any other aldehyde will give you secondary alcohol. Please note, if you want primary alcohol, you have to use aldehyde. But which aldehyde? The first aldehyde, methanol. You have to use methanol only if you want primary alcohol. Any other aldehyde of the homologous series, you will get secondary alcohol. Is that clear? Okay, methanol will give you primary alcohol. Any other aldehyde will give you secondary alcohol. So if you want a tertiary alcohol, what should you use? You should use ketone. You should use ketone because see, already 2 R groups are there. Third R group you get from Grignard reagent. Carbon attached to 3. See, the carbon to which OH is attached has 3 other carbon atoms. Tertiary you get. Correct? Okay, let's see. From ketone, see, that's ketone. R, C double bond O, R. Okay, with the Grignard reagent. R, MgX. The bond breaks. The carbon, this carbon will get this R. O will take up MgX. Addition product. Carbon already has 2 R. Another third R from Grignard reagent. So O minus MgX you have here like this. Okay, this is addition product. Which on hydrolysis? Okay, you get RCRR. OMgX becomes OH. MgM becomes MgOH X. And what is this carbon? CHOH, tertiary carbon. Tertiary carbon. Do you understand this? So, if you want primary alcohol, use methanol. If you want a secondary alcohol, any other aldehyde you use. If you want tertiary alcohol, use ketone. See example, you use acetone. Acetone or propanone. Propanone. See propanone. With CH3MgBr, methyl magnesium bromide. The carbon already attached to two CH3 groups. It will get third CH3 group from Grignard reagent. So this is the carbon, okay, functional group carbon, carbonyl carbon, okay, which will be CO will be converted into COH, okay, with the three CH3 groups. This is tertiary alcohol. This is addition product, adduct, which on hydrolysis will give you tertiary alcohol. Do you want me to explain again? Did you understand, guys? With the Grignard reagent, preparation of alcohol, reaction of carbonyl compound with the Grignard reagent. Did you understand? When I say Grignard reagent, we are talking about aldehydes and ketones. Did you understand? Good evening, Krishna Kumar. Good evening. Did you understand? Did you understand, guys? Is it clear? Is this clear? Okay. There completes your preparation of alcohols. Okay. Preparation of alcohol is done. From alkene and carbonyl compounds. Alkenes, acid catalyzed hydration of alkene. Okay, from carbonyl compounds by reduction and also reaction with Grignard reagent. Okay, okay. Now let's learn preparation of phenols. How do you prepare phenols? First method of preparation of phenol is from haloarenes. And which haloarene we are taking? Chlorobenzene. Chlorobenzene. Chlorobenzene is the haloarene. Haloarene in general. Chlorobenzene is the particular compound we are taking. Chlorobenzene. Chlorobenzene is the compound. We are going to convert. Cl is converted into OH. See how to do it. This is how you do it. You fuse chlorobenzene with the solid sodium hydroxide at 623 Kelvin and 300 atmosphere pressure. Fuse. Okay, you are going to heat and you are going to fuse these two compounds. Chlorobenzene with sodium hydroxide at 623 Kelvin and 300 atmospheric pressure. And what do you get? You get sodium phenoxide. Sodium phenoxide. Intermediate compound you get. Sodium phenoxide. Once the sodium phenoxide is obtained, just acidification is enough. Add the aqueous solution of hydrochloric acid. Okay, where sodium phenoxide ONA will be converted into OH. You will get phenol. Phenol is the product. So first fusing chlorobenzene with the sodium hydroxide at 623 Kelvin at 300 atmospheric pressure. We get sodium phenoxide, which on acidification will give you phenol. This is the first method of preparation of phenol. Is it clear? Is this clear? Preparation of phenol, is it clear? Yes. Okay, let's go to second method of preparation from benzene sulfonic acid. So this is benzene sulfonic acid. Benzene sulfonic acid. See, benzene sulfonic acid. SO3H group is sulfonic acid. So when you dissolve the benzene sulfonic acid, you get SO3 minus and H plus. So acidic hydrogen. Now how do you get benzene sulfonic acid? Reaction of benzene with the oleum. H2S2O7. That is oleum. H2S2O7. Oleum. When benzene reacts with oleum, H2S2O7, you get benzene sulfonic acid. Benzene sulfonic acid is fused with sodium hydroxide. Okay, sodium hydroxide. Reaction of benzene sulfonic acid with sodium hydroxide will give you, see, first step, it will give you this. What is this? O minus Na plus sodium phenoxide. Sodium phenoxide on hydrolysis with the acid. See, that is why second step written here. On acid will give you phenol. So here in this reaction together, that both steps are written together. So first you fuse it with sodium hydroxide, followed by reaction with HCl. Okay, acid will give you phenol. So sodium, benzene sulfonic acid, reaction with sodium hydroxide. Okay, will give you sodium phenoxide. Okay, sodium phenoxide. This is sodium phenoxide. O minus Na plus with benzene, which on acidification will give you phenol. How do you get the benzene sulfonic acid? Reaction of benzene with the oleum. What is oleum? H2S2O7. Now, if you want to remember oleum, okay, you can just remember like this. Add H2SO4 with the sulfur trioxide. SO3 and H2SO4 you add. So, 2 hydrogen, 2 sulfur, 7. See, add just. Sulfuric acid with sulfur trioxide you add. You will get oleum, H2S2O7. Okay, oleum, H2S2O7. So, benzene, when reacted with oleum, you get benzene sulfonic acid, which on reaction with sodium hydroxide, followed by acidification, will get you phenol. Is this clear? Is this clear? So, first method of preparation was from chlorobenzene. Second method of preparation is from benzene sulfonic acid. Now, let's go to third method of preparation from diazonium salts. From diazonium salts. And how do you prepare diazonium salt? By diazotization. By diazotization. Diazotization of aniline, aromatic primary amine. Aniline is aromatic primary amine. Aromatic is obvious because of benzene. Primary amine, you see, carbon is attached, nitrogen is attached to only one carbon atom. Nitrogen atom, amine group, nitrogen, functional group is attached to only one carbon atom. So, primary amine. So, aromatic primary amine, that is aniline, okay, is carried out diazotization reaction, diazotization process. Now, what is diazotization process? Reaction of aniline with the sodium nitrite and HCl. Sodium nitrite and HCl. When sodium nitrite and HCl reacts, HNO2, nitrous acid is obtained. Nitrous acid is prepared in situ within the reaction mixture by the reaction of NaNO2 and HCl. NaNO2 HCl in the reaction mixture in situ is called as in situ. That means within the reaction mixture, because this compound is not stable. So you cannot directly add nitrous acid. Like nitric acid, which is stable compound, nitrous acid is not stable. Okay, so nitrous acid is prepared within the reaction mixture by the reaction of sodium nitrite with the HCl. So nitrous acid thus formed will react with aniline to give you benzene diazonium chloride. Because HCl you have taken, no? That's why chloride. Benzene diazonium chloride. This compound is called as diazonium salt. Diazo. Di means 2, azo means nitrogen, 2 nitrogen, N2 with the plus charge. That is why NiUm. Diazonium. Nitrogen, 2 nitrogen atom with the plus charge. So you get diazonium salt. And the compound here formed when aniline reacts, when aniline undergoes diazotization is benzene diazonium chloride. Okay, this is a very important compound. How much important you will learn when you learn amine chapter. Okay, so thus formed benzene diazonium salt, just warm with water. Just warming with water is enough. Benzene will to benzene, OH is substituted. You get a phenol. Phenol is produced. Okay. So, diazonium salt is formed by treatment of aromatic primary amine, that is aniline, with the nitrous acid. And how do you get nitrous acid? Inside the reaction mixture by the reaction of sodium nitrite with HCl. Okay, at 0 to 4 degrees Celsius or at 273 to 278 Kelvin. 273 to 278 Kelvin, 0 to 4 degrees or 0 to 5 degrees Celsius. So, at very low temperature. Okay, diazotization takes place, you get a diazonium salt, which just warming with warm water is enough. You add the salt to warm water, you will get phenol. Okay, or dilute warm water, or even dilute acid. Dilute acid also will give you, phenol. That is the reaction. Did you understand? So this is the third method of preparation. So first method is of phenol preparation is from haloarenes, that is chlorobenzene. Second method is from benzene sulfonic acid, which is obtained from a reaction of benzene with oleum. And third method is from diazonium salt. And diazonium salt is obtained by diazotization. Did you guys understand? Did you understand? Did you guys understand? Any doubt you have? Any doubt? Okay. Now there is one more method of preparation, that is from cumin. So phenol prepared from fourth method of preparation you are learning. And the fourth method is cumin. Now what is cumin? Isopropyl benzene. See, this is isopropyl group. Isopropyl benzene is called as cumin. Okay. To isopropyl benzene, that is cumin, is oxidized in the presence of an air. Okay. In the presence of air has oxygen. So cumin undergoes oxidation to give you cumin hydroperoxide. See, to CH2, you are adding OO. This is hydroperoxide, peroxide bond. Okay, you get cumene hydroperoxide, which on treating with dilute acid, okay, treated with dilute acid, you will get phenol and acetone as byproduct. So cumene, isopropyl benzene is called as cumene. On oxidation, you will get cumene hydroperoxide. See, cumene hydroperoxide. Cumene hydroperoxide, which on treated with dilute acid, will give you phenol and acetone. Okay, phenol and acetone. So these are the most important 4 methods which you should know. Okay, to tackle your board exam or even any other exam, know how to prepare phenol. So 4 methods: from haloarenes, from benzene sulfonic acid, and from diazonium salt, and from cumene. It's very, 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 very important. Very, very important. I hope you understood. Any doubt, any question? See, any doubt you have, you can just post it here. Do you have any doubt? Did you guys understand? Okay, did you understand? Yes, very good, guys. Okay, then let's continue. Okay, next class will continue with the reactions of, before reactions, physical properties of that reactions of alcohols and phenols we will learn together. Then we'll take up ethers. Okay, yes. Okay, then next time's up. If you have no doubts, I'll wind up today. Thank you, guys. Thank you for being wonderful audience. Thank you.